Hi dear friends, good evening to all. My name is Sanjay. I am working with the reliability department in a big refinery. I have about 27 years experience working in a condition monitoring department in a reliability department, and I have some knowledge regarding vibration analysis. And in this term, unbalance is very important characteristic or parameter which we have to deal. So today with this video, I want to share some of my knowledge regarding the balancing or unbalance. Why the rotor are unbalanced and what are the types of unbalance, how to cure it, how to rectify it. All these things I want to share with you all and hope you will like this video. So let us start with the definition of balancing. Balancing is the process of distributing the weight along the center line of the rotor in a proper proportion or in balanced condition, so that there will be no vibration between the bearing. That is called as balancing. And reverse of it is called as unbalance. Unbalance means the mass distribution of the rotor is not even along the center line. That is called as unbalanced rotor, and it creates so much problem in the field while running. High vibration, then damage of the bearing, damage of the seal, then damage of the coupling. So many problems arises due to this unbalance criteria or unbalanced situations. So let us start with definition first. As I say, unbalance is a condition of the rotor or any machine, means uneven distribution of weight along the shaft or rotor center line. It is called as unbalance. Now we'll start from the thing that what are the causes of the unbalance. First one is manufacturing defects. While machining or while preparing some rotary part, there are always some tolerances in the field or manufacturing field, like they have casting, they machine it. If it is not machining in a proper way or in a proper tolerances, then it create unbalance. Second thing is while running the machine along the period of life, it create unbalance itself due to wear and tear or missing of some rotary part, damage of any rotary part, or deposition of the material, welding of the material along the rotor. It also create unbalance while running. Third thing is porosity or uneven built up the material or conditions, non-symmetrical condition like motor winding. If it is not proper way, then it create unbalance in a motor rotor. These are the some of the causes of the unbalance. Then what are the effect? As I said you that it creates high vibration definitely, and due to that high vibration it damage bearings frequently, damage the seal, very important and delicate part in the rotary machines. Then maybe damage coupling, and many other reasons or many other effects are uh, happen in the rotor due to this unbalanced criteria. Now we'll see what are the types which we have to face in a refinery. What are the types of unbalances? First type is unbalance. It's called as types. Static unbalance. What is the scenario in a static unbalance? Suppose this is our rotor. This is its geometrical center line. And take a note that every rotary machines or every rotor have another center line. It is called as a mass center line, where all the weight are concentrated along that center line. It is called as mass center line. And this is called as geometrical center line. These two center lines are different. Geometrical center line not change its place, it's always there. It is prepared, or we can draw a center line by taking a dimension of the rotor, exactly half. But mass center line not like that. Due to unbalance, it shifted anywhere. And if it is shift too much, then it get unbalance. Sometimes it shift parallel, and that mass center line we have one point that is called as center of gravity. Suppose this is our geometrical center line, and here is the center of this geometrical center line. Another is called as geometrical mass center line. Another is mass center line, where a CG is located. If these two center lines are coincide with each other, then it is called as perfectly balanced rotor. But in practical, not happen so. Always there is some angularity, always there is some offset, and because of that, always there is a vibration. Unbalanced force is created, and due to that centrifugal force of that unbalanced weight, it start vibrating. That is called as unbalance, the effect of the unbalances. Now, if that center line or mass center line is perfectly shifted parallel to the geometrical center line, these two lines, then it is called as static unbalance. Means all the weight are at one side, like this. When you rotate the shaft between the bearing, it always stay like high weight is bottom side. That is called as a static unbalance. That is very easy to cure it, rectify it. Just add some weight on opposite side or remove this weight. Either we can do anything. Just add some weight, same weight on opposite side, and then it will get balanced. Now, what is the another type? Second type, that is called as couple unbalance. Couple unbalance. In couple unbalance, what happen? It is not like this situation. This mass center line is shifted in such a way that it crosses from the point of that center of geometrical center line, but it is in angular way, like this. Suppose one weight is here, one is here, then this mass center line and geometric center line it in its place always. So this is a couple unbalance. Always we have to rectify this couple unbalance by adding the same weight in opposite direction. Same. Then only it will be get balanced. This is called as a couple unbalance. Now I am going to talk more about a third unbalance, that is called as quasi-static unbalance. Or in another language, it is called as dynamic unbalance. And this is the case always we found in a refinery, in the petrochemical industries. In this case, what happened? There is no static unbalance, no any couple unbalance, but rotor weight is shifted or transferred on such a center line. It is another way. Suppose here is more weight, here is little weight. Then center line will be go like this. Then CG will become somewhere here. Actual center line is center is here. This is called as quasi-static unbalance or dynamic unbalance, and this is the case we always find in our refinery. Now, how to cure it, how to rectify it, that is a big question. First thing, that we have to, if it is a small rotor, like pump, small turbine, small motor, then remove the rotor, go to the balancing machine or in a workshop, put it on a balancing machine, and the balancing machine tells you while rotating where is the unbalance and how to add the weight, where to add weight. In that way, referring to a standard 1940, we'll get some uh, proper tolerance weight, add it and cure it. That is final. Now, uh, in our case, we don't have only a small machine in our company. We have so many big machine also. That big machine not possible to remove each and every time, go to the workshop and balance it. We don't have that facility in a workshop. In that case, we have to do field balancing or online balancing, or in another language it's called as in situ balancing. On that balancing I want to talk more. For that we have to go in the field and do the balancing. I will explain it with a small polar diagram so that you will get a clear idea about how to rectify dynamic unbalance in the field for a big machinery. Suppose we'll go step by step. Okay. It is rotating like this. This is 90, 0, 180 degree, 270 degree. Okay. Then suppose this is rotating like this. Okay. So step 1 now. We'll go step by step. Step 1. First go in the field. Check a machine thoroughly. Check the safety provisions. What are the safety provisions are there? Check at what location manufacturer or OEM provided balancing things. Always each and every OEM or original equipment manufacturer give some characteristic or schematic where we can add the weight or remove the weight. So go check it at what we can add the weight, at what location, mark all the degrees, check safety provisions what are there, then be ready with a small weight that we have to add, like from say 0.05 gram to up to 5 gram, like this, 0.1 gram, 0.2, 1.5, 0.5. In that slot you have to keep ready all the weights so that it is easy to balance the rotor. This is our step 1. Step 2, now run the machine. No need to run the machine at full speed, because whatever unbalanced weight is there, it not change its self criteria, self weight. Suppose there is 10 gram of unbalanced weight is somewhere on the rotor, it is same, only the force is changed, vibration force is changed, and that force is about square of the speed. Means if you increase the speed by 2 times, then vibration force increases 4 times in a square proportion. So be alert about the speed. And small weight also magnifies too much vibration with a high speed. Keep that in mind. And another thing is, we may want to know what is the unit of vibration, that is gram mass multiplied by the radius from the center line, gram mm. This is the unit of the unbalance. Okay. Step 2 is run the machine initially. Say run up to 1000 rpm. This speed is sufficient to know where is the unbalance and how much it. Suppose you get about 70 microns at 120 Suppose you get a vibration about 70 microns at 120 degrees. Stop the machine. 70 micron is high vibration. So we have to nullify this vector, or we have to reduce this vibration. How to reduce it? We have to add a weight in such a way that same vector will be come in opposite direction and these two vector will be nullified. So we have to add the weight in somewhere on the rotor so that this vector of O will be nullified. Stop the machine now. We get one reading, that is O is equal to 70 microns at 120 degree. Now we have to add trial weight, step 3. Again, there will be two questions now. How much trial weight should be added and at what location? These two big questions in front of you. How much? We have one formula, okay, that is F is equal to 0.01 multiplied by trial weight multiplied by R multiplied by RPM, actual RPM, divided by 1000 a bracket square. F means 10% of rotor weight in kg. R means radius in centimeter. Trial weight means actual trial weight, we have to add it, what we have to add it in gram. So suppose weight is 300 kg, this F will come then 30 kg, 10%. Then R is suppose 10 centimeter, RPM is suppose 15,000. According to that, we will get about 2 grams of trial weight. Okay, we get some weight now, trial weight. Then where to add? Now we are balancing at 1000 RPM. It is a rigid pit. So high spot and heavy spot at the same place. So here is high weight. That's why it is creating high vibration at 120 degree. So we have to add opposite of this so that it will be nullified. This is our guess. So 120 opposite, this is 300. Opposite will become at 300. This is our guessing, or we have to add this weight here, trial weight, about 2 gram. So we get idea now where to add, how much to add. Okay, this is trial weight. We have to remove afterward. Keep in mind. This is our step 3. Add trial weight. After adding, check all the safety provisions there. Proper cover the coupling, all these things, and run the machine again. Now step 4. What will happen now? Again we will get some unbalanced effect of vibration. Say we will get vibration at about 225 degrees Celsius, and its magnitude is about 50 micron. That is O plus C. 50 microns at 225 degrees. 225 will become somewhere here. Okay, this is O plus C. Why I am telling this O plus C? Because now whatever operation we got is the effect of original unbalance, whatever available in that machine or rotor, plus whatever we added trial weight here. The combined effect is came here about 50 microns at 225 degree. Now the magic start. Now we will go for step 5. What we have to do? We have to find out the effect of only trial weight. For that we have to subtract this vector O vector from this O plus C vector. Not a big calculation for that. If you just check how to add and subtract vector, because it will become big video. So just from this end add one vector, that will give you a subtraction. That is C. By adding from end of the O and closing to C, this will give a C vector. Then we have to shift C vector to center. It will come like this, approximately say 280 degree. So this is C vector now. Okay, just shift from here to here. Now check the scenario. I add trial weight here at 300 degrees Celsius. I got its effect at C at 280 degree, about 20 degree counterclockwise direction. Means if you add the weight here, then effect I get effect here about 20 degree in counterclockwise direction. So what we have to do now? We have to remove this weight and add in such a way that the effect will become exactly opposite to this here. For that we have to shift like this little bit. If I shift this weight a little, suppose 10 degree, then this weight will be away 10 degree. Like this, if I shifted it 20 degree, then it will be completely come opposite to this O vector. This is our location then. So we have to go at 320 degrees Celsius to get nullify this O vector. Then only we can nullify this vector and we get a balancing. Now another we get now location at 320 we have to add. Now how much final weight we have to add? Very cross multiplication just it. We get vibration. We have to measure this one now. Again, sorry. We have to measure this one. How much it came? Suppose it came about say 100 micron. Now just do the cross multiplication. Okay. 100 micron is equal to 2 gram of weight. Means 100 micron for vibration, we have to add 2 gram. So for 70 microns, how much? Just do the cross multiplication. 2 multiplied by 70 divided by 100. So it will come about 1.4 gram. So this is our final weight. We have to add at 320. This is our final location. (320 degree) and weight will be 1.4 gram, approximately 1.5 gram. So just go there, add about 1.5 gram at 320. If you add this weight of 1.5 gram at 320 degrees Celsius, then effect will become 20 degree upwards counterclockwise direction, and it will be nullify this 70 micron vector, and we get our rotor will get balanced. So dear friend, this is the system, or this is the steps. These are the